Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Tarun, who has just completed the course Linux Basics, and he'll be giving us a presentation on that. So first of all, begin by seeing a demonstration of his code base running on the real robot, and then we'll get into the details about how he managed to do his project. So I will now hand over the platform to him so that he can begin his presentation. Alright, whenever you're ready, Tarun.
Okay. Shall I continue, sir?
Yes, go ahead.
Okay. A warm gathering to one and all gathered here. Myself, Tarun. First year. I am a first year mechatronics student from Pondicherry, India. I have come over to know about the construct while I'm searching the about the ROS. Then, at first of all, I started my path in the Python 3 in construct. But I have shown this Linux so that we can go ahead with the Python 3. So I done my Linux course in this Construct Academy. So okay, let first go present with my PPT. The power of ROS, Robot Operating System. We know about that every Windows or every system running in the in its own operating system, like Windows, Mac OS, and Linux. For us, the ROS will run good on comparing to other OS. Linux it is a better one to do. So that we are taking the Linux to in the highest preference. In this course, I have come over about the word gazebo. The gazebo is a stimulator, and also we are having that RVIC. In RVIC, it is a vector-based form. What are the sensor will move? It will move or 3D vector-based dynamics. While in the gazebo, it's a stimulator. It will stimulate the movement. It will stimulate the motions and everything. Okay, let's go deeper to our content. I have done my part. I have done this course with the help of the Turtlebot 3. It has some specification because it is normally it's an obstacle. It may use in a many way, like obstacle avoiders, mapping and navigation system, since in many other ways. It is and also this is the first time I am interacting with a real bot. Okay. I have done a obstacle avoider script as well as a statistics based script. These two are different, mostly similar. It will change in few difference. Let me go deeper to it. In an obstacle avoider, it is an infinite loop. First of all, it is for to read the sensors data, to compare with the threshold, and to make the decision using the if-else statements.
Okay.
It will run in an infinite loop through help of a while loop, so that it will run throughout the loop until and we press the Control C. Control C is a terminator to stop the program.
Okay.
I have developed many functions to control the bot, like moving forward, like moving right, left, to take the decision to turn right, to take the decision to turn left. It's based on that. Okay, one second. In the statistics script, let will compare with us. The obstacle avoider script is like our brain to make the decision, as well as the robot statistics script is like our hand to show the gesture, to show the like our mouse, we are expressing something now. It's based on that. It will interact to the terminal so that we can see what is running, what the bot is doing. It will print the mathematical uh, steps to know about to know the bot behaviors, like moving in this direction for this many in this velocity for these many seconds, like that. Okay, let go with our stimulation.
Mm-hmm.
For that, first of all, we are launching the turtle bot so that we can operate the bot as a virtual form. First of all, we will see how it is running the gazebo as well as in the RVIZ. Then we can move to the real bot.
Mm-hmm. Can you enlarge your RFs, please, so we can see?
Okay, sir.
All right.
Telling me to zoom it.
Yes. Oh, just make the window bigger. Yeah.
Okay, just a minute. Uh, Due to some issues, let will try again.
Okay.
Okay, it's good. Let me change the angle to the top view so that
Okay.
we can see the movement of the bot.
All right.
Let it be here. Okay, let's open our new terminal
Mm-hmm.
to run the interference script so
Mm-hmm.
that the bot will interact with these two terminals. First of all, we are telling the path where the files is located. In that, we are running our script. We got the ready message so that we can launch the other programs. Okay. It's successfully setting the parameters so that we can come over that. It is detecting the surrounding and analyzing the surrounding through the sensors.
Mm-hmm.
In the another terminal, we okay. And it's a model dash. Okay. In the right corner, we can see that the bot is moving in the RVIZ screen.
Mm-hmm. Very slowly though. What velocities did you set?
I cannot. Once again, sir. Now we are running the statistics program so that it will. We can see now here. It is showing the degree and the direction of the bot is moving.
Mm-hmm.
Let we see the deeper view or enlarged view of the RVIC.
Mm-hmm.
Once it detected the obstacles, it will turn its own direction. I written the code to turn it as in an angle of 45-degree so that it will rotate itself to in a good manner. Due to network issue, it is running it a little bit slower.
Mm-hmm.
Okay. The vector is moving, right? It is turning. Okay. It is turning.
Can you check how much time you still have for the real robot?
To the real robot, sir.
Yes. Can you check how much time you have left? Because I think we can do the simulation at any time.
Okay,
But
okay. I will done it. Let I close these terminals.
mm-hmm. So
Okay.
okay, I think you should connect now, and you try it on the real robot before you are out of time.
Okay. Okay, sir. That's right. Right for ready. Okay. we can see that the real bot is moving
Mm-hmm.
in this channel. Side by side, we can run the statistics program also.
Okay.
The bot is changing its direction. That will be once it find the obstacles, it will stop and it is turning
Okay.
to the direction where least there is a least obstacles.
Okay.
It's moving. Once it found the obstacles, it will stop and turn this direction. I have set the threshold to the zero point 0.3 meter, so it will detect until the zero point 0.3 meters.
Mm-hmm. Why did it not go straight? It seems like there was a lot of space right in front of it.
What's
When it was in the corner, it seems there was a lot of space right in front of it. Why did it not go straight?
uh, it it it's a basic program, so we can if we change some values, it will do good.
Okay. All right. I think with reference to your code, there should be something you should be able to give a comment about why it had to consider rotating again. But you can do that afterwards. I'm just trying to let you know so that you can think about these things as you go on. Okay.
Okay, sir. Okay, sure.
Mm-hmm. For example, right now it's clear right in front of it, but it keeps rotating. You see what I mean?
Yes,
Yeah.
I should change the angular velocity. Yes.
Maybe not exactly. You should probably check more often the obstacles in front of it, because once it's clear, there's no need for it to keep rotating, right?
Okay, sir.
You see, like right there was nothing in front of it, but it kept rotating. So when you are taking in the laser scan data, there is something that you are doing excessively. For example, it turns 180 degrees out of the way when 90 degrees could just do, right?
Okay.
It's like it's looking for obstacles, right?
Sure, sir. I will change. I will correct my mistake.
All right, so let's wait for it to do a couple of more obstacle avoidance, and then we can terminate.
Okay. Is it okay, sir?
All right, yeah, it's fine. So can you now show us your your base script, right? The naive obstacle avoider that you developed for this robot to be able to do what it's doing.
Okay, sir. This is my script, sir.
Okay. Can you take us through, go through what you did, how you're taking in the laser scan data, what are you doing in each loop, right?
Okay, sir. Just a minute, sir. Let me turn. Okay. First of all, I have used the I have used the, oh, just a minute. First of all, I will use the bash script so that it's calling the source function. It is a dictionary. It's calling the source which has the data of the functions, sensing the readings data. It's get, and then first of all, the robot should not move. So I set the parameters to the zero,
Mm-hmm.
both the linear velocity as well as the angular velocity.
Mm-hmm.
Then I have set the threshold to detect the distance so that it will stop prayer. I have set it to 0.3 meters.
Okay.
Then it's going into the while loop and getting the values of left, right, front, also other front, right, front, left.
Okay.
Totally to five values.
Okay.
Those five values are comparing with mostly those three values front, front, right, front, left are comparing with the threshold.
Mm-hmm.
Then it's going into the if else condition, nested if else.
Mm-hmm.
It's checking with the parameters right, left, or if zero, if it's lower than the threshold frequency, that it is rotating. We can see here.
Okay. How did
I
you
have
get
set
that
the
value?
angular velocity.
How did you get that value of how much it's supposed to rotate, right?
Okay, so I have referred the this simple patrol flash, but if we calculate the angular velocity, we can give the particular correct value. So
Mm-hmm. Because this is the value that also will help you to determine for how long it rotates and how much, right? So,
yeah.
um,
So
you
if we change this value, then we can rectify the mistake where it's
yes,
rotating to.
exactly.
Okay, sir.
That's where I was going. Yeah. So if you understand how you get to these values, you'll be able to correct those overcompensation that you see.
Yes, sir. Sir, just a minute. Let me turn on my battery so that it will. Okay, 1 minute. Same process is doing in the nested if else.
Mm-hmm.
It's checking the other parameters like front left, front right here. Let me zoom it. It's checking. Then it's turning the angular velocity. And also we are setting the time because if we are just setting the angular velocity to rotate, if we set the correct time or else we can, instead of changing the angular velocity, we can also reduce the time, so that the turning time reduces, the degree of turning will be reduces, so that we can control the bot turning.
Okay.
And we are offering the angular velocity. Same process is doing in multiple if else conditions. Same for each and every parameters.
Okay.
Then finally, the while loop is ending.
Okay. Okay.
So this obstacle avoider script is to check and make decision to turn in which direction.
Okay. All right.
Okay.
Okay. Let's now
Let
go to
go
the
with,
robot state. Yes, that one.
okay. Yes. It also has the same loop condition, while loop.
Mm-hmm.
It will run until we stop the program, or pressing the control K to kill the foreground process.
Mm-hmm. What is the
Controlling
purpose of
press.
what is the purpose of this script? Why did you develop it?
This
Right.
script is like, okay, sir. This script is to interact with the terminal
Mm-hmm.
in a mathematical way.
Mm-hmm.
In how, okay, sir. What, sir?
Yeah, go ahead. It's fine. I was saying yes. Okay.
Okay. How it is interacting with the bot. The program is how is interacting with the bot, so that we can come to know that the bot, how, in which speed the bot is moving, in which direction. It will tell all these data.
Okay. Okay.
It's getting the direction. This is printing the distance covered in the meters.
Mm-hmm. So it's like it's the one that's give you the feedback of what the robot is doing, right? Odometry data and all.
Yeah.
All right. All right.
It this line command tells the direction orientation of the direction position of x-axis, y-axis, z-axis.
Mm-hmm. Mm-hmm. Okay.
Same, printing the IME angular velocities, orientation. This print the velocities, print the orientation. This print the acceleration. Finally, it ending its while loop. The script is ended.
Mm-hmm. All right. All right. Thank you very much, Turan. Anything else that you'd wanna show us?
Nothing, sir. That's it.
All right. All right. So you just hang in there. All right. We'll wrap it up here and then. Alright everyone, so this was Turan's presentation. Congratulations to him, and would like to encourage all those of you who would want to try the courses we offer certification on to do so. And until next time, keep pushing your ROS learning. Bye bye.